Hello everyone and welcome to this WEU episode where we are going to continue our STM32 tutorial, and this time we're focusing how to create a function for the ADC peripheral. And from this function perspective, we are going to build really function that will have extremely an extreme flexibility. So to set up the pin as an ADC, how to set up the pin as an ADC, and how to read the data. And for this time, we will have not only one but two input from the potentiometers. We will be reading the data and checking when we change the values of these potentiometers, we are able to read the data. And you can see it's 4 lines of code to have 2 inputs. So that will be optimizing a lot your code. So if you are interested to learn how to set up an ADC for the STM32 and understand how to optimize the function actually to create this very simple and clear function that will help you to make your code, this episode is exactly for you. Okay, within this chapter, we will start initially as usual by reviewing the circuit that we will use. So later on when we'll create our function, it will be quite simple and obvious what we are going to do. After that, we will create the library files, which means by here the adc.c and the adc.header. So we prepare those files and we can directly use them. Then we will start building the function called pin analog set function. And this is the function that will transform, you just put as an input the pin, and then this function will set the pin to pin analog and make everything happening. But during the building of that function, we will have to understand how to create a way to map all the channels with the pins. After that, we will go to the pin analog read function. So setting the pin as an analog is one step, but also reading it is another one. So we will separate them. They can be within the same function, but just for understanding purposes, so people will understand which pin is set to which way of reading, we will separate them. Finally, we will have a live test and some optimization to the code. And for today, we are going to use the board, the STM32F4 Discovery, and the microcontroller would be the STM32F07VGT6. Good, so without further ado, let's jump to the next one, the next step, which will be the circuit review. So this is the circuit that we do have. Let me make it a little bit bigger so you can see it well better. So this is here, the circuit that we do have here. And from connection perspective, we do have a slide potentiometer, which is this one, connected to one side to the ground and the other side to 3.3 volt. And also we do have another potentiometer called the rotary potentiometer, which is this one. Yeah, let me show you this. This is the rotary potentiometer here. And this rotary potentiometer also from the both extremity is connected to the 3.3 volt and to the ground. And from that perspective, we do have the PA1 connected to the output of the linear potentiometer or the slide potentiometer, and PA4 connected to the rotary potentiometer. So we will use this time PA4 and PA1 as a analog input for our example. Okay, so let's jump to the next step where we are going. So, and also now I think we don't need any more the video for the moment, and we can start by creating the file library. So before that, as usual, I always try to start from scratch so you can see how I set up my KEIL initially. So let's start by creating a new project and go here, not this one. So I prepared the folder and I will call this one ADC functions. Okay, and my microcontroller, as we said, is the STM32F407VGT6, and this is what I'm going to choose. And I will be using the KIMSys core and also the device startup. Okay, And I will set up here my device just in case. So it's my STM32 F407. And here I will be calling this one the app. Let's use a capital letter for the E. And also let's add another group. We call it headers. Headers. Okay, perfect. As a starting point, I'd like to also add the code we have done the previous time, because that code was extremely useful. We are not going to use at all this time, but as a guidance, that would be something very helpful, and add the gpio.c and clock.c. So I'm closing this one. And for the headers, I will be adding the H files that I created previously. So now I'm inheriting all the work that I have been doing in the previous tutorials. Everything is available on GitHub, so you just download it. So we will go to the main here, and we do have those steps here, which are extremely helpful. So here we start seeing this warnings, and to remove these warnings, the code is properly correct, but to remove those warnings, you just go to this. Yeah, sorry, I've been jumping too fast. So you go here for this option for target. You go to target ARM compiler. You just put 5 and then 6 here, and you go back. You go to the C/C++ tab, and you choose here the C99, and also from optimization you take the -00. Okay, and as we are in the option for target, we go to the debug, we select our ST-Link debugger, we go to setting, we see that the serial number is identified, the connection with the ARM microprocessor is also set up properly. We go to flash, we put reset and run, and then we disable this one so we can have a reset each time when we load the code. Okay, and you can see that automatically every warning has disappeared from here. And we are going now to start by creating the ADC.c file. So we go here and we add a new element. So it just, no, not double clicking. And we add a new item to the group, and it will be a C file, and we call it just the ADC. So we have the ADC.c, and here we add a new element to. It would be an H file that we will call also ADC. And you can see now that I do have an ADC.c file, which is here, and an ADC.h file, which is here. And this is my library that is ready. We are ready to use. Okay, so my next step will be to start building the pin analog set function. And I prepared a small snippet just to show you what we are going to build. So in this ADC.c here, we are going to build this function, this pin analog set function, and this is what we are going to start from now on. And inside it, we will need some functions to make our code less complex and modular. So we will have two good things. After that, inside it too, we need to have an ADC mapper. So this is another function, and there's another function we need to build, and we will see every step. And then we need to find them to map with a function, so we don't have each time a manual job to do that. Then we will be working on the ADC analog read. Okay, and to make things more efficient, so let's start by including a few things. So let's include the library here, the F4XX, and this is the standard library to connect all the registers and to have the structure register, so we don't have to spend time just looking for the registers, which is a non-added value activity. We can also add the gpio.h, and also we should not forget to include the adc.h also. So we do have all the library that we need to build. Okay, so without further ado, we can start this function. So let's copy this void here. Okay, so within this function, we will need to have two inputs. For this one, we will need to have the ADC. So it will be a char, and we call it ADC. And also the other input, it will be an int, and this int will be the port pin. Okay, so we will need two things: which ADC are we going to use, and which port pin we need also that to be the input for the analog. And inside this one, we will have those functions here that we need to build. So initialization of the ADC itself. And to get back a little bit and understand what we are doing, as you can see here, we do have those activities that we already start creating. So just to jump back and start creating it. So let's go here and start building this ADC in it. So we do have, first of all, 3 ADCs, but we are going to start making the code within the same ADC. So let's create this function here. We call it this ADC init. ADC init will initialize, will be doing this job. First, going to the RCC, or the enabling the clock, then enabling the GPIO, and after that doing this CR2, this the enabling on and off for the on and off for the ADC actually. Okay, so let's copy here, and we can put for the moment a void for this one, and this one will be taking also the ADC init will be taking only the ADC itself. So let's take this one, and we will put as a char, it will be taking ADC. Okay, so on this one, for the ADC itself, what we need to take, first of all, is bringing this RCC init. So let's start by initializing our, or enabling our RCC. So let's create it here, void, and we have this enable, and this one also, it's in HR ADC. Okay, so let's make this one bigger so you can see more clearly what we do on this one, and we open here. This should have removed every error that we do have. So now we need to enable the RCC, or the ADC, the analog to digital. So let's go here, and if we go to the RCC clock, this one, and we go to ABP2 enable. So let me just remember. Yeah, it's the ABP2 enable. Let's bring it back. ABP2 enable register. This one. So you can see that it's really simple and straightforward. If we do have the ADC is equal to 1, or the ADC1 is 8, ADC2 is 9, and ADC3 is 10. So this is quite giving us a really helpful way to manage that. So if we do have ADC1 equal to 0 and ADC2 equal to 1 and 3, it's a straightforward function that we can build. And this is what we are going to do. So we go here, we go back to ADC here, and enabling the ADC become very simple. So it's RCC, and as we said, APB2 enable register, which will be or equal, and then let's open here, and that will be a 1 that is pushed by 8, and not only 8, 8 plus the ADC. So this is, so if my ADC is 1, or sorry, the ADC 1 is mapped to 0, then this one will be just 8, and it will be changing. So let's go back here. It will be just changing the ADC 1. If it's 2, then it will be equal to 1, and here ADC 3 will be equal to 3. And to build this function, or to build the data which is coming with this one, we can create quickly kind of a ADC's data. So we put an enum here, and we call it ADCs, and we open a small one where we put ADC 0 or ADC 1 is equal to 0, ADC 1 equal to 0, ADC 2, and ADC 3. Okay, just, yeah, forgot that, like this. So this should be, yeah. Now all good. So we do have everything set up correctly, and we will use later on the values of this ADC to map it. Okay, so here immediately what we need to take is calling this ADC init. Just copy this, and by putting this one here and removing the char, we have immediately the ADC that we have here activated or enabled at the clock perspective. Okay, so most of the job is done here. Then there's another function a little bit hidden we have been using for many times now, is getting the ADC, which ADC we are using, or identifying the ADC. So let's go here. So now we need to identify, because we need to activate that ADC. Here, identify the ADC. And this function will have a type that is already defined in this STM32F4 function. So what we are going to do is getting, we call it, so first the type is ADC type def, and this is a pointer to the ADC itself. And we will like to have it as a pointer, and we can call this one get ADC. So we are getting the ADC as an input here. It will be a char and just the ADC that we are going to input. Then we start writing our code, which should be a conditional one. And let's create the type itself. So ADC type def, the variable that we would like to have, and called here. So we call this one ADCX here. And then we put a condition, a switch condition that we need. So, and we are going to return the ADCX here. Okay, good. Hope up to now everything is clear. Please ask questions, put in the comment area. Be more than happy to answer. So we are going to put a switch based on the ADC value, and we start some question about this. So first of all, case 1, if it's equal, case ADC1, so if it's equal to ADC1, then my ADCX here will be equal to ADC1. And this is predefined within this STM32F4. Next, and after that, we need to go break. Okay, so let's copy this one another time, but here, because not all the microcontroller have multiple ADCs, the STM32F4, some family have only one ADC, so we need to confirm, we need to use the if, this if defined. So if defined for ADC2, so if the ADC2 is defined, we can use the same thing here. So ADC2 and this one ADC2. there's a mistake. Yeah, because I need to put the and if, and that should be good. I copy it again, and we add this one. For this one, ADC3, ADC3, and ADC3. And we do have the function that will be returning the ADC that we are going to use for the rest of the code. Okay, so we just copy this function here. So we need to define also to get this one, because we are going to use it again. Here we are getting this one, and we will put it equal to get ADC. So we target the ADC that we want from the perspective of the code or the selection of the user. ADCX, it will be based on the ADC that has been asked by the user. And after that, when we reach that point, we can start playing with our ADC exactly like here. So we just now take those one and we can copy them like this. We can copy those one here and bring this one, and instead of using ADC1, we use the ADCX here, and we do have everything here used quite well, and we have fully initialized our ADCs and ready to use it. Okay, so this is good. This is what we want to do, but we can also still use this function in an interesting way. As we got this value of the ADCX, we can still push it here. So let's copy this one first and bring it here. Okay, and we are going to get this ADC. And what we can do, because we need to have some activity here, so we activate, but we still need to add the pin channel mapper, and this also will be using the map to the ADC register itself. So we getting this one here and change it a bit, so we can copy this one and also change from void to here. And by having so, we can return this value, and we don't need to go again to the same function again. So we can copy this initialization for this function and assign that value, get the ADC. Okay, so you can see now I do have direct access to the ADC that I have selected using the ADC and the port. So this is step one. And then after that, so now we initialized our function. The next step is to get the map of the ADC. And this is a little bit complicated activity. So let's just start by creating this one. So it will be returning a char. So we go here, and that will be returning a char, which will be this one. And we need to enter 2 elements actually by having this. So why I have an error here? What's going on? Void expected. Okay, let's check. Yeah, that's because I do have this one. That should now correct things. So here, yeah, return value. I need to input for this one also the ADC and the port pin. Okay, so now this should be okay. Why I still have an error? Does not have a return value, which is fair, quite a fair thing to say. So for this one, we are going to have a char. We call it channel, and this one will be equal initially to 0, and we would like to return the channel. Okay, turn channel like this. That should correct the whole thing. So for the moment, I think I can close this one and focus here. So how to do that? And let's go quickly and get back to the problematic that we do have. So what we would like to do is to go here, and this is the map that we do have between the ADC and the pin. So here, if you go, you can see this ADC1, for example, ADC1 channel 10 is mapped to PC0. ADC1 channel 11 is mapped to PC1, and so on through all the pins. Not all the pins are mapped, but how the pins that are connected to the ADC. To do so, we will need to map anyway everything. There's no clear mathematic formula, and that should be quite written in a strong way. So here, yeah, we are in the new chapter now. So we are mapping the channels. So on that, we need to create a map, and there is no a lot of ways to do it. Just someone have to do it and copy all the map, and this someone is unfortunately myself. So you do have the whole map here, and here I've been mapping every pin and port to an ADC and the channel. So you have the whole thing, not only for this STM32, but all for the all STM32 families. And we do have with that, so we do have the pin channel map array, and also you do have the dimension of that array. So you do have also the dimension of that array. And to use that within the function we created, so let's close those one here. So let me bring this one here. To use those one in the function, we will need to loop through everything using this. And to do so, we can go in this channel. So sorry, in this function, we have int I equal to 0, or int I, just int I, and start a basic loop. So for I equals 0, I equals 0, I is less than, and we need to loop through all the pin channel, the rows. So less than ADC pin and the pin. So we are going through all the rows one by one, and after that I++. And inside the loop, we check if on this one, if our port pin that we have as an input, so port pin here, if port pin is equal, so there's two conditions going on. If port pin is equal to the ADC, and we need to put the table here, ADC pin map, this one of I, and then let's close it, and this one is 0. So the first one, so if the port pin, and we go here, is equal to this one, and we go here again, the ADC is equal to the same thing. So we just copy again this one, this. We don't need to the equal again, but here 1. So if we do have the port pin is equal to this one, to the port pin in this map, and also the ADC is equal to the ADC within this map within the same row, then what will happen is the channel is equal to the number 3 or number 2. So position number 2 here. And we can return channel then. So this is how we are going to do it. And now we are mapping our channel. We are mapping our channel and find it within this database that we have added, this one here. Okay, good. So we do have this function. We can then just copy those two ones here and bring them back here. We can bring them back here. And of course, as we said, instead of having the one that will be an X and here an X, because we already selected our target field, target register, but from the channel now, we can have here the channel. We put it like this. Here, channel will be equal to the ADC channel mapper, and we can put it as an ADC equal to the ADC or to the port, here the port pin. So the variable are quite simple and goes directly. So this one channels, and here instead of putting 1, because we have been looking for channel 1 is connected to PA1, now we just need to know the port by inputting the port, and we get that immediately. So let's put here channel, and we do have our ADC fully. No, sorry, I forgot one step, one important step. We need also to activate the GPIO. And on this one, so we can delete this one because we don't need it anymore. And here, we can copy the whole thing and bring it. So here, where we activate. So this one's still very valid here. Super valid here. Now we initiate the pin, the clock, and GPIO. So we can remove this one. So this one, GPIO, we don't need the A because it whatever the, and this one pin is set to analog mode. And here we just need to give them the port pin and everything is done. So imagine now you do have one function where you give the char, the ADC and the port pin, and the job is done whatever the pin that you do have. That's kind of a very useful function if you are in, like, you would like to customize as much as you want your code. So this is extremely helpful. So now we set up the whole thing. Let's close these functions here. And we can jump to the next one. So let me go here and go to the next little chapter that we do have, which is the pin analog read function. So let's take here. And as we said, the pin analog function is will need how to say it. The pin analog function, it's coming back. The ADC is a 12-bit, so the output is an int. 12-bit is up to 4095, so we put as an int. And here, and the input also here, we need to have the char of the ADC and also the int, the port pin. Okay, let's start building that quickly. So on this one, so we do have, we need to have int, let's call ADC value here equal to 0. And by the end of the day, we need to return the ADC value. Okay, that should remove every, okay, perfect. So first of all, what we are going to do is to get the ADC value, and this is something we have been doing a lot, not here, but let's use the ADC init function, this one, not the mapper, but get ADC, this one. So let's take this. We also need to get, and we just, it's extremely a lot of kind of simple copy paste here. So now we have targeted and we found our ADC. And what we have seen the last time is here when we read the data. So we need to activate the ADC. But before that, there is a little bit of update that we need to create on this one. So let's go here and check something. So we need to get also the channel, because we need to confirm which channel we are reading. So channel here, which will be equal, and we can put it directly equal to this. So let's bring this one here. And so now we do have our channel. And after getting our channel, we need to make a small check on this one. So we can put, not even put a small check, but we can do the same thing we have done before. So let's go here and let's put this one like this. So what we have done on this one, so reading, before reading operation, so this, and so this is about reading, and we need to put X here and X here. So we keep using the registers of the ADC that we have selected. And we need also, if the channel, so we need to put a small condition because we are going to change the pin. So if the pin is changing, and because we do have only one ADC can be reading a lot of values. So we need to activate for certain pins. So we check here and we go if the channel is different. And this is, which is extremely important. So if we are using a different pin, is different from the ADCX, which one? Not this one here, this one. So if my channel value, if I'm reading a different channel, then I need to reactivate or rearm my ADC. So I go for ADCX, putting actually this one should be equal to the channel. And also after that, I need to reinitiate my code. So going through this one. Okay. Anyway, I can run it before here. So if no, or run it later. Again, we start the conversion. So I can put an else. That would be more elegant here. So I put else and put this one. So if I do have a different pin, so if I'm using a different pin, we need to change the channel, and then the 30 here that we have been seeing, and I made a mistake on it. If I go to the ADC here and I go to the register and we go to the CR1, the CR2 actually, and this one, start conversion of regular channel. So if I have a new pin, if I'm reading from a different pin, first change the pin, then start the conversion. Else, if it's the same pin, I'm asking to start the conversion again. Okay, so after that, I will be waiting until the end of conversion is happening. And when this finish, the conversion is happening, what we can make is ADC val, the one that val will be equal to ADCX. We can just copy it from here, this one, and put it here. Yeah, we don't need this one. And then we can delete the whole thing that we do have here and remove even this one. And I can remove this for later application. So now what I need is only include the ADC.h. I can remove those one and start copying. So we completed the read function, the whole read function, and let's make everything beautiful and clear so we can see. So let's copy this one and we go to adc.h. Let's make it bigger. We paste it. This is the analog read, but before that I would like to analog set, and this one also is analog set. So we have everything set properly to be ready. So add here, and we can, here we said that we have PA4, PA1, so PA1 connected with, we do have a linear, I forgot the name, is a linear, probably different name, linear potentiometer, and the other one, the PA4, is connected to rotation potentiometer. I'm sure the name is different, but my brain cannot code and do these kind of things at the same time. So let's start by setting up the PA1. So pin analog set. So this is what we would like to do. Pin analog set, and we do have first the ADC. We can put ADC1, and after that, that will be the PA1. And we can copy this one. Yeah, PA1 does not here because I need to include the GPIO.h. I can copy that and paste here and have PA4. Okay, good. So after that, now we can start reading the data. So let's create two variables. So we call them in, and this one will be a linear potentiometer. No, linear, I don't know how to write linear suddenly. Okay, L, we call it potentiometer, that's equal to 0. And also the R potentiometer, that will be equal to 0. Yeah, we put an R, and that should be good. So let's put here R potentiometer, or with L, will be equal to pin analog read for ADC1, and then we need to put PA1, and also we can get the R potentiometer, this one for PA4. Let's start by save and build. We do have a 0 error, 0 warning, which is extremely good for the moment. And let's quickly jump then to load the code and see what's going to happen. And to read the data for the moment, we just go here and we start putting these two values to the watch list here and here, adding them to the watch list, and also put this watch list to normal binary decimal numbers. So now we are running the code and something is not working properly. So there is an error happening. So let's check what's going on. So let's reset, run. That works. This is working. And let's check here. Okay, so here we do have some error is catching up. So let's go to the ADC and let's start by seeing what's going on, first of all. So we go to the peripheral and go to ADC. We go to ADC1 and start try to understand what's going on. So start of conversion is okay. And here that's working. Okay, too many breakpoints, fair enough. So we go back here and check. We don't need those one anymore. Okay, we do have the values are coming. Okay, so we do have two values. So let's check. So I will make it a bit bigger later on, but let's check the value. So we go, let me bring back video here. Hope it's visible. And now I can run this one and see the value are changing. So I'll be moving both of them to see. So I'm moving the linear potentiometer and it seems nothing is happening, or both are having the same value, which is not what I'm expecting. So you see both of them have exactly the same value, and this is the error I was worried about previously. So let's go here and check again. And this is probably coming from this condition. So I need to read the channels. Channels probably is working properly. And here, if channel is different from here, I need to start the conversion. So let's check what's going on. So let's see if we do have an error on that. So we run again. We are reading the values, which is good. And let's see when we jump here and we go inside the function to see, okay, let me hide this. And we see what's going on within this function here. So pin analog read, trying to read. So we go here. So, and to see what is inside the function, we can see within this value using the hexadecimal. So here, let's check the channel. So the channel is different for the moment. And if we go here, we do have the SQ1 is equal to 1, which is good. So it's different. It finds that it's different and it's set up to the right way. Perfect. After that, it goes and it reads the data. So let's see again on the watch list. Both of them are same where I'll be changing. So both of them are reading from PA4. So let's confirm what's going on and if I have missed something. We may also need to confirm, did I set up the whole thing properly? Yeah, this is a kind of best part of the coding is the one that find a way. So it just, let's put a breakpoint here. We do have SQ1 is equal to 4, which is channel number 4, and this is what we expect from here. But still, what is reading, so if I go to the next step, it's reading right, and then it goes again, L potentiometer. Okay, we do have the two values here. Okay, something. Okay, I think the error is I'm not waiting for the end of conversion. So let's check. So this one, I'm waiting SR2. Let's check what do we have. End of conversion flag is okay. Let's check this one. So let's make a different thing, just in case, because sometimes the reading speed is higher than the check itself. So let me add another int I will call EOC that will be equal to 0, end of conversion. So now let's check. Let's put this one here. And I put EOC here while EOC is equal to 0. So I need this one. And I put EOC is equal to ADCX and 2, just in case. We make it like this. So let's save and build, and then load the code, and after that go here. Now let's run it and see. So now by just doing this trick, you see that I do have two different values. That was the trick. So I needed to put the flag, isolate the flag in a variable here, and keep checking until the flag is equal to 0. Then the while loop has worked. So now let me bring back and see how the values are working. So I do have this linear one. So if I do like this, you see that the linear now is 4095, and if I push to the other side, is almost equal to 0. Where if I play with the rotational one, here I put to the maximum. So now this is the rotation, the rotary potentiometer is working, and I can change both of them. Okay, so we do have two functions now working. The read function is working well. So we had our live example working properly. So, and this is the chapter is quite late by putting the chapter name. Now we can create a few things for optimization and improvement of the code. We are going to optimize the way we are calling this pin analog set with ADCPA1 and also how to read it, because we don't always need to have the ADC one. We can automate that one a little bit, and also how we can optimize the function itself. So let's go to ADC1. This is the analog or the setup of analog for the pin itself. So each time, if we have within the same ADC, we would like to use different pins, we will need to each time initialize this one. So we can go over that one if the ADC has been already set up or already activated. To do so, we will start by static chart. Here I created a pin ADC or ADC, we call it ADC set, sorry, ADC1 set, and let's use set as a small letters or small characters, and we initiate it as a 0. We copy the same and we paste it again and again. For this one will be 2 and 3. So each time, if one of these ADCs has been already initiated, so let's put like this. This is better. So we go back here and we start working on it. So for the initiation itself, first we check if the ADC is equal to ADC1. Then another check, if check ADC set, where is it? ADC set, where's ADC1 set? Yeah, that's where is equal to 0. So if it's equal to 0 means it has not been activated before, then we can initialize the ADC and set our ADC 1 to 1. So from the next time, if we want to activate a pin under a certain ADC, we don't need to do it again and again. We can put an else here and copy the whole thing. And instead of having ADC1, that will be everything for ADC2. Finally, we copy it again and we go here, and that will be the ADC3. So all the ADCs are covered. So this 1 and 2, and there's no repeating or repetition when we activate a certain pin to be an ADC. This is the first optimization that is proposed. The second one is to make your life much easier and better. And this one is to having a certain pin ADC set function. So we call it's a void pin ADC set function. And for this one, we just would like to have an int port pin. Okay, and inside it, pin ADC set. Inside it, we will be having using directly this function. We'll be calling this function where the ADC here is ADC1 and the port pin will be the same port pin. So that will be fun function without the ADC1. That can be a little bit sometimes a little bit not helpful. So we can make the same. So ADC2, ADC3, and you just change 2 and 3. So you don't need to know exactly which ADC you are using. Exactly same here for this function too. For the analog read, we can have a function that will be called pin, and we call it ADCRX like this. And for the input variable, we will have only the port pin, and we will see later on how nicer it is to have that one. So that will be a return. We are going to return this function, the ping analog read. We put it here, where the ADC is ADC1 and the port pin is exactly the same. So we just copy this one again, and we go back. Let's copy it properly. We go here, and this one will be ADC2, ADC3, and this will make our life much easier and much comfortable. So what we can do after that, we can go here and open it. Yeah, so we close this one because we don't need it, and we just copy those new functions that we have just created. So I will copy only one, and later on in the code that you will find in GitHub, you will find all the function copied. Just doesn't make sense for you guys to watch me copy and paste all the time. Okay, so we do have our beautiful new functions. So, and we can go here, and instead of pin analog set, we have a pin ADC set function for PA1. Let me close it and zoom a little bit and copy this one, comment this one, bring this one to life for PA4. And after that, so we can also do the same thing here. So this, we copy this and we comment this line just for you to see the difference. Pin ADC RX for PA1. And finally, we can just copy this, comment this one, and we go here, and would be the rotative potentiometer, and I would like to read the PA4. Okay, so we completed the whole thing. We can just save and build. Zero error, zero warning, all good. So I can load the code and go for the debug mode so we can read the values here. So let's run from debug mode. Let me show you the camera here, and we start testing a little bit. So by moving this one, the rotative one, so you see it goes to almost 0, and now I'm moving the other one, the linear one, and you can see that this linear is not actually moving. So let me check why this is happening. Yeah, this is when you code, just code, you don't copy from nothing, and sometimes something is not working properly. So let me go here and check port pin properly well, and we do have this one working. So let's check it again. I understand what's happening. What's happening is very let me bring it back to show you. This wire is not connected anymore. So let me connect it to the 3.3 volt. And now this is, the code was good. So now I'm moving the linear one. The linear one is almost 0. And when I move the rotative one, the R1 is going, it's not moving actually. The wire is, yeah, it's moving. So now I'm moving it back up to 0. Yeah, and working properly. Okay, that was all the code. That was everything we have reviewed together. You have seen sometimes we can go through a little bit of challenges, but it's always something that helps us to learn. I really appreciate a lot you watching this video. It has been a great pleasure to share it with you guys, and see you in the next episode. Again, thank you so much and have a great day.